Okay, happy Friday. We'll get started here. Today's lecture we'll look at subsetting. Subsetting is the idea of kind of taking some kind of data structure and just getting the elements that you want out of it. This is based largely in part on the chapter on subsetting from Hadley Wickham's Advanced R book. So this is your related reading that I recommend, and a lot of my examples and things some of these are taken directly from his textbook. So first we'll start off with subsetting atomic vectors, which I think you're all familiar with, but we'll look at a few examples and just kind of go over it. So first we start off with this vector x, and it's got the values 2.1, 4.2, 3.3, and 5.4. They're not in order from least to greatest, but the value after the decimal, that 0.1, 0.2, 0.3, and 0.4, kind of indicates the position in the original vector so that you can kind of see how these things work out. Okay, so I think we're just familiar with subsetting using integers, and so we can say, hey, I want x single square bracket, and we do vector 3 comma 1, and that's going to pull out the third element and the first element in the order that we specify. Order x is a function that we apply to x, and what it does is it returns back the indices of the elements that you would need in order to put the vector x in order. So if I subset x using this vector order x, okay, which is basically saying take x and give me the first element, third element, second element, and fourth element here, then when you do that, it will put the values of x in order from least to greatest. First element, third element, second element, fourth element. X is basically sorted, okay? So x subset on order x is basically the same thing as sort x. Sort x just returns the values of x in order, but sometimes you want to know the ordering of the values here, okay? If you put in the same value multiple times, so you do x square bracket 1 comma 1, okay, vector 1, 1, then you'll get back that first element twice. If you put in anything other than an integer, not anything other than an integer, you put in a floating point number, okay, what it does is it truncates the value. So 2.1 gives you back the second element, 2.9 also gives you the second element. It doesn't round, And so there are, a few kind of edge cases, and we'll talk about floating point math a little bit later, but there are some cases where values look like, you might have something like 1.999999999, and it looks like the number 2. When you print it out, R actually shows you the number 2, but it's actually not the number 2, it's the number 1.99999. And so if you were to put that into your operation, it will it'll just give you the first element here. Okay. Here you can also use negative integers, and that will just exclude those values. So you can say, hey, give me x, but not the third and first elements, and you get the second and fourth elements. But you can't mix negative and positive things because that's just weird. You're saying here, you're asking x, I want x, but don't give me the first element, but do give me the second element. And R just gets confused and says, what do you want me to do with the other stuff? If you only wanted the second element, why don't you just say you only wanted the second element? Why did you tell me you didn't want the first element? So it says only zeros can be mixed with negative subscripts, and so we get that. I'm going to go through a lot of examples very quickly, so just make sure you take some time later to kind of review these notes. Here we've got... we can also subset a vector using a logical vector. I think we're also very familiar with this. So here, again, if I have x and I say I want subset true, true, false, false, we're going to get back the first two elements, okay, and we're not going to get the third and fourth elements, okay. Here I have a comparison operator, x greater than 3. X greater than 3 is going to return a logical vector, right? It's going to be true for these elements. It's false for that 2.1. And so basically I'm going to get X subset on false, true, true, true. And therefore I get back elements that are greater than 3. There you go. Here I have a logical vector that is shorter, and so it recycles. So here I say subset X on true, the vector true, false. That true, false gets recycled into true, false, true, false. And so we get the first and the third elements. Okay. If you have an NA in your logical vector, then it will always kind of correspond to an NA. So here I say subset on true, true, NA, false. Well, it's going to give me the first and the second element, gives me an NA for the third one, and then does include the fourth one, false. Okay. And here I got true, comma, NA, and it recycles. So give me the first one, NA. Third one, NA. Okay, so it recycles true NA, true NA. There you go. A couple special cases. If you put in nothing in your square brackets, you'll get everything. Okay, now this is probably not useful for an atomic vector, but when it comes to, say, dealing with matrices, where we might want to only specify which rows we want, but we want all of the columns, then putting in nothing is helpful. Okay, nothing gives us everything, right? Versus something like in Python, you have to put in the colon operator with nothing on each side to kind of indicate you want to slice out the whole thing. But again, that's beside the point. If you put in a 0, okay, you'll get a 0 length vector. Again, you don't generally do this on your own on purpose, but a lot of times if you have a function and you want to test out your function and see when will my function break and things like that, it's often helpful to throw in a 0 length vector to just kind of see, hey, is this going to break my function? Because if you include that in some kind of program or some kind of loop or something, and you have some kind of operator, sometimes your function, your operator returns a 0 length vector, and then if you feed that into your function, is it going to break it, right? Like if you do which elements of X are greater than 10, and you don't have any elements of X that are greater than 10, so if I say X is 1 through 8, and I say which X is greater than 10, okay, I get a 0 length vector, right? And if you have a function, you might want to might want to test that out to see, hey, is this going to break if I put in a 0 length vector? And so you can also get a 0 length vector just by doing square bracket 0. Okay. In R, you can also set names to the elements in your vector. So here I've got a vector Y, which takes the elements of X and gives the names A, B, and C, and D to the elements there. And so if you have a named vector, you can subset the vector using the names. So here I'm going to say, hey, I want elements named D, C, and A, and we get those values, okay, corresponding to the names D, C, and A. Yeah, question?
Is set names a user-defined?
No, set names is a base R function. Sets the names in an object. I guess it's in the stats package, but it gets loaded up in R. So that's a thing. And there's a couple also handy vectors that exist. Letters is the lowercase letters, and all caps letters are just internal values here. Okay, that are helpful in case like if you just need to name things, you don't have to type out A, B, C, D yourself. You can just use the letters vector. Like integer indices, you can repeat indices, and so you can say, give me AAA, and you'll get that same element multiple times. If you have names, you have to spell them exactly the same. So here I've created a vector Z with the values 1 and 2, and the name for 1 is ABC. The name for 2 is DEF. This is another way to set names when you create the vector itself. And if I say, hey, I want A and D, it fails because there's nothing called A. I need to type out ABC, and there's nothing called D. So I get NAs. A handy application of having named vectors and subsetting using the names is creating a lookup table. So here I have this vector of values, M, F, U, F, F, M, and M, okay? And let's say I want to create, let's say I want to replace all instances of M with male, all instances of F with female, and U with NA, or something like that, okay? So here is, what is lookup? Lookup is a vector, character vector, with the values male, female, NA, and the name for male is M, the name for female is F, the name for NA is U. And I can subset this lookup vector using the elements in X, the values in X. And so because I can repeat indices here, it's going to look up M, and it'll put out male, female, NA, female, female, male, male. All right. So basically, I've replaced all of these things, and to kind of just get just the values without the names, you can use the function unname, which will just drop the names there. Okay. In your homework, there is a task where you have to translate month names. Okay. And there's lots of ways to approach the problem. But I think a fairly elegant solution is to use a named vector and a kind of a corresponding lookup table as well. So so that's one possible approach that you might consider for kind of replacing one name with another name for the months and stuff. All right, let's talk about lists. Lists are going to be very important, and so subsetting a list works similarly in the way we subset an atomic vector, but there's two different subsetting operators that we have to work with. There's the single square bracket and the double square bracket, and understanding the difference between these subsetting operators will be very important. Okay, so the analogy from Hadley Wickham that I also like to use is to think of a list as a train with cars, okay? And the single square bracket returns the train cars themselves. So it always returns a list, okay? So if you think of a list as a train, a series of train cars, single square bracket always returns the train cars, always returns a list. Whereas a double square bracket returns the contents inside the train car, okay? And so you can use, so if X is a train carrying objects, X square bracket, single square bracket, 4:6 will give you a train with cars 4, 5, and 6, whereas X double square bracket 5 will give you the object inside car number 5, okay? And therefore, this double square bracket can't be used with kind of a range. You can't say for double square bracket 4:6 because a list can contain different objects, different types, right? You could list train car 4 could be carrying a vector. Train car 5 could be carrying a function. Train car 6 could be carrying a matrix. Okay. Now, if you say I want double square bracket 4:6. And you pull out those objects, how do you return that? You can't, okay? So you can only return the train cars carrying those train cars 4, 5, and 6, which kind of compartmentalize them, but you can't extract all three elements at the same time. You can say, I want the element inside train car 4. I want the element inside, or the object inside train car 5. That's fine, but you have to do it one at a time. Double square brackets are designed only to be used with one element in there at a time. Let me go ahead and give you your first view quiz answer. First view quiz answer is the letter B. B as in bear. B. Okay, so here's just kind of a little picture. X is a train of length 3. Inside the first car is a vector 1, 2, 3. Second car is a vector with the character A. Third is a vector 4, 5, 6. So X single square bracket 1 returns a train with that first train car. X double square bracket 1 returns the element inside there, which is the vector 1, 2, 3. A few more examples. So here's again our original list X. X single square bracket 1:2 gives me a list with these kind of two train cars, two list elements. -2 drops out the second train car, and I get a list with this. X single square bracket 1 comma 1 gives me that first train car but duplicated. Okay, and X single square bracket 0 gives me a list but with no train cars. All right, so here I have a named list. The train cars have names A, B, and C. And I can say double square bracket 1, that will give me the element inside that first train car, which is the vector 1, 2, 3. X double square bracket A gives me the element inside the train car named A, which is also that vector 1, 2, 3. Here, if I say X single square bracket A comma B, then I will get a train car, or a train with 3 cars, car A, car B, and car B again. Now what's happening here? When I say X double square bracket A comma B, this doesn't work. I get something called subscript out of bounds, which feels weird, okay? This feels weird. Well, let's explore this in a little bit, but let me show you a contrasting example where this actually works, okay? So here, I am going to create a list X, and inside list X is another list, okay? So I'm putting basically like a train inside that first train car, okay? So X is a train with 2 cars. Inside that first train car is another little mini train with called A and with 2 cars called A and B. And so here, this says I want on the top level train, the big train, give me the contents inside that first train car. What is that? That's going to be the little mini train. Okay, and then here I'm saying inside that mini train, give me the element inside the train car called B. Okay. And so that says, oh, okay, yeah, that's the character B. This thing right here is equivalent to this. So when you have double square brackets and you give it a vector, A comma B, it is effectively doing this. It's doing X double square bracket A and then double square bracket B. Okay, and so this works here. Okay, whereas back here. Here I said, here's X, and again, this X here is just a train car ABC. And so here I'm saying, hey, give me what's inside train car A. And then I'm saying inside train car A, give me the contents of train car B. And it says, there's no train car B. There's no train car B, right? I just have a vector 1, 2, 3. There's no train car B, and that's why it's giving me subscript out of bounds. So in my opinion, this is much more clear than this, as far as what's happening. This says, okay, look inside train car A. Once you're in there, look inside train car B. And to me, that makes sense. This is a little bit less clear, but this is how R translates. When R sees something like this, inside double square brackets, it's doing this. Okay. So recursive subsetting, I don't personally recommend it, but it is possible. Okay. Here's another example. Here I got list D, length 3. The names are A, B, and C, and you can always ask R structure. Give me the structure of this element or this object. Structure of D, and it says, oh yeah, that's a list of 3. That first element is called A, and it's a numeric vector. That second element is called B, and it's a logical vector, and the third element in the list is called C, and it's a character vector with just the letter A. So the important distinction is that single square brackets, again, always return lists, and double square brackets will return the object inside the list. So D single square bracket 1 gives you back that first train car. It's a list of length 1. So it's train car called A. And when you ask what's the type of on D single square bracket 1, it says it's a list. D double square bracket 1 gives you the element inside that first train car, inside that first list element. And that's the numeric vector with the values 1, 2, 3. And when you say type of on D double square bracket 1, it says, yeah, that's the numeric vector, type double. Okay, here's another list. Again, length of 3 elements in the list, but now we don't have any names, okay? We don't have any names, and so when you ask what is the structure, it says it's a list of 3. We don't have any names on these things, okay? And so you can still refer to every object inside this list, even though they don't have names. And the way R does this is when you print things out, you have all of these double square brackets all over the place, right? So here I say L1 single square bracket 1, okay? And in order for R to distinguish that this is a list and not an integer vector, it returns, when it prints out what it's returning, it goes double square bracket 1, followed by single square bracket 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so sometimes, when I was first using R, I'm like, why are there all these double square brackets? What is R outputting all of this stuff? This is so you, the user, can distinguish between, is what R giving me back a list, or is what R giving me back a vector? Okay, whereas here when I subset L1 using the double square bracket, this returns a vector, and to indicate that, I just have the single square bracket 1 here, right? Okay, so that's it. And we're all accustomed to how R uses these single square brackets when it outputs vectors, right? And so this is just so you can kind of keep track of where you are. So here I have this letters vector, single square bracket 1 to kind of indicate that the first element is an A, and then it hits the end of the printout of the screen, and then it rolls around to here, and it's R. And what is the R? R is the 18th element in my vector here, and so that's why I get a single square bracket 18 there, okay? So that's what's going on. And again, this is the double square bracket indicates that the output here is the list. Here, what's going on here? I got L single square bracket 1, single square bracket 2, and I get back double square bracket null, okay? So what has happened? I have taken the list, and first, R reads this first part here, and it says single square bracket 1. Okay, so I want the first train car. So L single square bracket 1 is now a train with just one car in it. And then I'm saying, give me the second train car. Okay, and R's like, there's no second train car here. You already subset it down to just one train car. So when you ask me for the second train car of this thing, okay, it says there's nothing there. So it says, yeah, that's an empty train. Okay, all right. Whereas this says, okay, go inside that first train car and look at what the object inside there is. Okay, so again, the object inside is this integer vector. So we're saying go inside that first train car and then give me the second element. Okay, and it says, yeah, that's the number 2, no problem. Okay, what is this? L1 double square bracket C1 comma 2. This is the recursive subsetting. This is equivalent to doing L1 double square bracket 1 double square bracket 2, and so that's very similar to this thing where it says go inside the first element, and once you're inside that the first element, will give me the second element there, which is the number 2. Okay. Okay, so again, here's just to kind of make things more complicated. Here I'm putting a list inside of another list. So L2 is a list of length 3, where the first train car contains L1. So L2 is a train, length 3, list of 3. Inside that first list element, inside that first train car is like a mini train, okay? L1, and that itself has three elements. And again, none of these things are named. So how do we refer to all of the different elements, right? We need a way to be able to refer to each thing, right? If I say, hey, I want the letter lowercase d, how do we get that, okay? Or whatever we're talking about, we need a way to reference it. So you're gonna see all of these square brackets, double square brackets all over the place. And you know, when you're first kind of working with lists in R, it feels a little like, oh gosh, this is hard to read. But my only comfort is like, you'll get used to it. I don't know. The more you use it, the more you'll get used to it, right? So So here, if I do L2 single square bracket 1, what is that? The structure there is we're taking the first train car of the top level list, and within that first train car is a little mini train of length 3. And to kind of indicate that, R prints out a whole bunch of square brackets. So I got double square bracket 1 to say, hey, this is my first list element. This itself is a list of length 1. And then to indicate that inside that list element is another list, and what are the elements inside there? We have double square bracket 1, double square bracket 1. This is saying inside the first train car within the first train car, right? Now this is double square bracket 1, double square bracket 2. Inside the second train car that's contained in the larger train car, inside the second element there. All right, and that's this vector A, B, C, D, and then here's double square bracket 1, double square bracket 3. Okay, is that okay? Does that feel all right? Okay, and so, yeah, when we say, what is the structure of this? It's a list of 1, and within that list of 1 is a list of 3. Okay, if you do L2 double square bracket 1, then it just says, hey, what's the element inside that first train car? That's just a list of length 3, and so this is just the output for how R prints out a list of length 3. Less complicated there. And if you say, what is the structure of L2 double square bracket 1? Yeah, it says, yeah, it's just a list of length 3. Okay, so this is how we refer to all of these different elements. Okay, so L2 double square bracket 1, single square bracket 1, that's saying, okay, look inside the first element there. All right, so we're looking at there, and we get what we see is a train, and I say, give me back the first element of that train. That's going to be a train car. This is a list of length 1. Inside that list is this vector of length 8. What happened here? Well, when I run this L2 double square bracket 1, single square bracket 1, what it returns is a list of length 1, where inside that list is this integer vector. But this part is a list, and so when I ask what is the second element of this list, well, that doesn't exist, right? That doesn't exist, so I get it back a null. Okay, but if I do double square bracket 1, double square bracket 1, then we get back the vector itself. And so if I do double square bracket 1, double square bracket 1, single square bracket 2, that will give me the second element here. And then I get the number 2. Sorry for the weird behavior of the screen. Okay. All right. So I guess, it feels almost comical with all of these square brackets and double square brackets, but it's important that we can distinguish between these things, okay? All right, let me give you your second view quiz answer. It's the letter D. D as in dog, D. Okay, so here is a atomic vector. Values 1, 2, 3, names A, B, C. You can actually use double square brackets on vectors, and they behave almost the same, except if it's named, it'll drop the names. And how it handles out-of-bound indices is different. So X single square bracket 1 gives us back the first element with the name A. Double square bracket 1 gives me back the first element without the name. Okay. But this is what happens when you give it something that's like an out-of-bound index. So X here is just a vector with values 1, 2, 3, integer vector 1, 2, 3. If I do single square bracket 5 and I give it an out-of-bounds index, I say, hey, what's the fifth element on this length 3 vector? R says, hey, I don't know. It gives me back an NA. Okay. Here, if I do double square bracket, I get an error. It says subscript out of bounds. It says, give me back the fifth element, extract out the fifth element on this list, and it doesn't exist, and so this returns an error. So R will run here, R stops the code here, okay? And so sometimes you want your code to stop, and you would use this. Sometimes you want to kind of keep running and just kind of treat it as a missing thing, okay? if you give it a length 0 vector, okay, like a null or any kind of thing that's a length 0 thing, here this will give you back a vector of the type of x, so x is an integer vector, and it gives us a length 0 integer vector. If you use double square bracket with a length 0 vector, then we get an error that says attempt to select less than one element and get one index or something like that, okay? So we get an error here. Similar kind of behavior when we're dealing with a list. So here I have a list L1 and it's length 3. If I do single square bracket on the list and I say, hey, give me the 4th element on this length 3 list, I get back a list but with a null, right? I get a list with nothing inside. Whereas if I say, hey, extract out the 4th element from the list, there I get an error. If I say, hey, give me what is subset the list to a 0 length vector, I give it null here, I get a 0 length list, an empty list. And if I do L1 double square bracket and I give it a 0 length thing here, then I get an error. Okay, so similar kind of behaviors with single and double square brackets when you give it either 0 length vectors to subset on or an out of bounds index. So, subscript out of bounds is kind of a common error that you encounter, and this frequently happens when you write some kind of loop and your stopping condition just might not be set entirely correct, and you run into this kinds of things. That often happens with matrices and stuff, but also with lists and whatnot. Okay. All right, let's talk about subsetting matrices and arrays. And I think we're kind of familiar with this, but there's a couple things I want to kind of highlight and point out here, right? So here's a matrix, 3 by 3 matrix with the elements, with the values 1 through 9. The rows are unnamed, but the columns are named A, B, and C. And so we can subset using commas to indicate which rows we want. And I can say I want the first and second rows, comma, nothing to indicate I want all of the columns, and I get the first and second rows. Here, I can give it a logical vector for the rows, and so I can say TFT. So this is not good habits, but T and F by default, T corresponds to true and F corresponds to false. I would recommend always using true rather than all caps true rather than T, because T is not reserved and you can like assign the value 0 to T or something like that. And then if you do that, that will like break this, right? That would break this. Okay. Whereas if you try to assign 0 to true, it says you're not allowed to change the value of true. Okay, so I recommend always kind of using true and false, all caps true and all caps false spelled out. But just in a pinch, you can use T and F. But T and F aren't reserved, and they can be reassigned to different values, which can throw things off. Okay, or F, if F takes on any value other than 0, it's going to start acting like true. Okay, so things could happen. Okay, so but anyway, you say true, false, true, and so that's going to be I want the first row, not the second. Third row, yes. I want columns B and A, and it returns that in that order. Columns B and A in the first and third rows. 0 says give me back none of the rows, and give me the columns other than the second column, and it does that. And so there's actually no values in here, but we do get the column headings. It prints those out. When you subset a matrix down into just kind of a row or something, it simplifies by default into a vector. So when you ask, hey, is A a vector? It's going to say, oh, no, there's a dimension attribute, right? It's a matrix. It's not a vector, okay? But when you subset A down to its first row, okay, then it pulls out these values 1, 4, 7, and it simplifies it down into a vector. This is just a vector of values 1, 4, 7. Okay. Internally, though, matrices are just atomic vectors with dimension attributes. Okay. So here I've got this matrix vals. Okay, which just takes the first 25 letters of the alphabet, A through Y, and arranges it into this 5x5 grid. Okay. And you can just say, so to get like the letter H, I could say, I want the third row, second column. Okay, and I could do vowels 3, 2. Here, I say, I want vowels 8 and 9, and I don't have a comma after that. So I just say, hey, I want the 8th and 9th values. And in that case, R just returns the 8th and 9th values, which would be, so R always counts down the columns. So 1, 2, 3, 4, 5, 6, 7, and 8. 8 is H, and 9 is I, and gives me back H and I. You can also subset a matrix with another matrix, subset a matrix with a matrix. And this matrix here, the rows will correspond to how many elements you want, and the columns will correspond to how many dimensions are in the matrix. So this matrix is 2 dimensions. So basically each row corresponds to a coordinate, okay? So here I'm saying I want, so this is a 4x2 matrix, and I'm saying I want first row, 5th column. Then I want the element in the 3rd row, 1st column, okay? So I want first row, 5th column, I want the U, I want 3rd row, 1st column, we get the C, and you can kind of go through and pick out what letters you want there. Okay, so here I've got 4 rows, so we're going to return, when I subset the values on this matrix with 4 rows, I'm going to get 4 elements, each of these things specifying the coordinates of the thing I want. I would say this is not very common. We don't usually do something like this, but it is possible, okay? And there might be some use case where you want to do something like that. This can be generalized into higher dimensional arrays. So here I have a 3-dimensional array with 2 rows, 3 columns, and 2 sheets or 2 layers, okay? And so here I've got that. And so I can specify, similarly, a matrix. Here I've got 2 rows saying I want 2 elements, and each row has 3 coordinates. So here I'm saying I want first row, 2nd column, 1st layer. First row, 2nd column, 1st layer. And where does that take me? That takes me first row, 2nd column, 1st layer, the number 3. Okay. And the other one I think was 2, 3, 2. 2nd row, 3rd column, 2nd layer, 12. And we get 3 and 12. Data frames. Data frames internally are stored as lists, but they look like tables when they print out. So R allows you to subset data frames the way you would subset a list. It also allows you to subset data frames the way you would subset a matrix. Okay. So here I start off with a simple data frame. And again, a data frame internally is a list with vectors of equal length. So I have the first column has 4 elements and it's called X. 2nd column has 4 elements, it's called Y. 3rd column has 4 elements and it's called Z. And so here I can subset the data frame using a logical vector with a comma to select which rows I want, right? So this part right here, oh gosh. This part right here is a logical statement, and with the comma, it's going to select the rows where this logical statement is true. So my logical statement is look at column Y, df $y, do mod 2 equals 0 is basically saying where is column Y divisible by 2 and has no remainder. So it's true for the first row because 4 is divisible by 2, false for 3, true for 2, false for 1 here. So it's true for the first and 3rd rows, and so it will extract out the first and 3rd rows, okay, where this thing is true. Okay, I think we're kind of accustomed to seeing this. You can subset a data frame like you would a list. So here I can say give me the elements called X and Z, and the list elements correspond to kind of the column names. So we get back columns X and Z. Similarly, I could also do df, give me all the rows, comma, the columns X and Z. and I get all the rows on the columns X and Z here. Here I can say I want the first and third rows, and I put in a comma here. So I have df first and third rows, comma, all the columns, and I get the first and third rows. If I forget the comma, though, what's going to happen? What if I leave out the comma? What am I going to get? Yeah. It's going to give me the first and third columns, okay? So single square bracket here, it's going to give me the first column and the third column, okay? So first and third row with the comma. If you leave out the comma, it's going to give you the first and third columns. Yes?
It's going to give you the first and the third row, but all the columns.
No. It's wait, what?
For the next
So
one.
this previous one, yeah, this will give you the first row and third row, comma, nothing, so all of the columns, okay? So all the columns for the first and third rows. Here, I just said 1 and 3, so this will give me the first and third columns. Okay, if you have, in data frames, your columns kind of always have names, and so you can say df square bracket x, and you will get that preserves the fact that it's a data frame, okay? But if you put in the comma and you say x, right, then this will simplify it down to just that vector, okay? So there is a difference between when you just kind of use a single element, okay? So df square bracket x preserves that it's a data frame in with this df comma x here will simplify it down to a vector. $x always simplifies, and double square bracket also simplifies down to just kind of elements there. Couple things where R will simplify versus preserve, and this is just a kind of few examples here. So we already went through some differences between single and double square brackets on atomic vectors, where the behavior of out of bounds indices and zero length things are different. And again, another thing is that if you have names, the single square bracket keeps the names and the double square bracket drops the names. Okay. For lists, the single square bracket always kind of preserves that it's a list. Double square bracket simplifies down to just the element inside that list. With factors, you have this option. When you simplify a subset of factor, you can include this optional argument, comma drop true. And what that will do is it will drop any unused levels. So here Z is a factor with levels A and B. And so when I subset down to the first element, it just says, hey, it's A, but it preserves the fact that there's levels A and B. Here, if I say subset down to the first element and I say drop true, it drops any unused levels. With a matrix, it simplifies the default behavior. So here, if I say A, 1 comma nothing, that's going to take the matrix, return the first row and all of the columns, right? So A is a matrix 1, 2, 3, 4, 2 by 2 matrix, 4 elements, 1, 2, 3, 4. And so when I say 1 comma, it gives me back that first row, 1, 3, and it simplifies it down to a vector. With a matrix, you can actually throw in a second comma during the subsetting operation and give it this optional argument, drop equals false. So here I'm saying I want the first row, all of the columns, and I have this argument, optional argument, drop equals false. And in that case, it will preserve the matrix structure. So here you're saying, hey, I want the first row, but when you return that first row, I want you to keep it a matrix. I want it to be a matrix with 1 row and 2 columns. And so this is a way to kind of preserve the matrix structure there. For data frames, again, single square bracket will preserve that it's a data frame. Double square bracket will extract out the thing and simplify it down to a list. All right, so let's go over a couple examples. Let me give you your third view quiz answer. Third view quiz answer today is the letter E. E as in elephant. E as in elephant. Okay, so here I have this data frame. It's called MT cars. These are all kind of, I don't know, this is an old car. I don't even know what this vehicle is. A Valiant? What is that? Now I'm curious. Sorry, detour. Valiant car? No? Plymouth Valiant. Look at that. Oh, geez. Okay, well, there you go. That's what it was. And so anyway, 6-cylinder vehicle, 18.1 miles per gallon. He had these different kind of things. These are the row names. These are column names. And let's just try some subsetting operations here. All right, what's happening here? I want to select the cars where the number of cylinders is less than or equal to 5. So I did MT cars $cylinder less than or equal to 5. And I get an error. It says undefined column selected. What's going on? What did I do wrong? Okay. Yeah. I'm missing a comma. And why am I getting undefined columns selected? Okay. So when you do MT cars $cylinders less than or equal to 5, okay, I'm going to get what? False, false, true. I'm looking at this thing. False, false, true, false, 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 true, true, etc. Okay? And so I'm subsetting on a logical vector, right? And I don't know how many rows are in this thing. Maybe there's 30 rows or something. And so maybe I get to like element 18 and it's a true. Well, I didn't put in a comma, so it's trying to subset like a list, okay? And so this list, how long is the list? It's as long as however many columns I have, right? The first list element is MPGs, next element is cylinders, so on and so forth. I think I got 11 columns here. So I've got a list of length 11. And when I say, hey, I give it a true-false vector of length 30 or something like that, and I'm trying to select the 18th value. The 18th value is true, but my list is length 11. So now I'm getting this error, undefined columns selected, because I'm trying to select some kind of column that's not there. So yeah, it's fixed just by kind of including the comma. And now I'm saying, hey, select the rows where this statement is true. Select the rows where this statement is true. And then we get all of these things, cylinders less than or equal to 5 here. Okay. What's going on here? Okay. Here I got MT car cylinders equal 4 or 6. All right. So when I run this, however, I get back 6 cylinders, 4 cylinders, and I still get what, 8 cylinders here, right? The Hornet Sportabout. I'm really curious what these things are. And the Duster 360. Okay. I'm still getting these 8s. What's going on here? I said I want cylinders equal to 4 or 6. This is the OR operator. What?
You must again type the empty car cylinder equals 6.
I must type in empty cars cylinders equals 6, okay? For this to work. Why? Because what's happening back here is that this OR operator is going to kind of coerce what's on the left and the right into something logical, right? So on the left, I have empty cars cylinders equals 4, and I'm going to get, true, false, false, true, false, 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 true, etc. Okay? And then on the right-hand side, it just sees the 6. Okay? The OR operator coerces this into a logical value. So what happens? When you coerce things into logical values, anything that's not a 0 gets coerced into true, right? 0 gets coerced into false. Anything other than 0 gets coerced into true. So basically on the left, I have a vector, false, false, true, false, false, true. On the right, I just have true. And so when I do the OR, that true gets recycled and everything just becomes false or true, true or true, false or true. Everything just becomes true, and that's why it's returning all of the rows. So yes, what we have to do is I have to do empty car cylinders equals 4, or empty car cylinders equals 6. And then that's going to work and we have this. There's actually a better operator. There is the percent in percent operator. And so you can do something like MT cars, $ cylinders in the values 4 or 6, okay? And that will give you basically the equivalent of MT cars cylinders equals 4 or MT cars cylinders equals 6, okay? So these two things are equivalent. So the in operator, I think, is a better usage there. Okay, we're out of time. So the last thing, something similar here. Again, undefined column selected. Just review this. I gave you all view quiz answers, right? All 3 of them. Okay, so we will go ahead and end here for today. Have a great weekend. Monday is a holiday, Martin Luther King holiday. So we will see you on Wednesday. So have a great weekend, and we'll see you on Wednesday.